Understanding of computation thus provides benefits similar to a basic knowledge of physics, chemistry, and biology in making sense of the world and tackling many real-world problems more effectively. This aspect of computation is often referred to as computational thinking. A major goal of this book is to emphasize the general nature of computation, and thus the wide applicability of computer science. My hope is that this will spark a broader interest in computer science and a desire to learn more about it. I first identify computation in everyday activities, and then explain corresponding computer science concepts through popular stories. The everyday situations are taken from a typical workday: getting up in the morning, having breakfast, commuting to work, episodes at the workplace, a doctor's appointment, a hobby activity in the afternoon, having dinner, and reflecting on the day's events in the evening. Each of these 15 vignettes introduces a book chapter. The chapters then explain the computation concepts using 7 popular stories. Each story spans 2 or 3 chapters and deals with a specific topic of computer science. The book has 2 parts: algorithms and languages. These are the 2 main pillars on which the concept of computation rests. Table 1 summarizes the stories and the computer science concepts they'll illustrate. We all appreciate a good story. Stories console us, give us hope, and inspire us. They tell us about the world, make us aware of the problems we face, and sometimes suggest solutions. Stories can also provide guidance for our lives. When you think about what stories have to teach us, you probably think about love, conflict, the human condition. But I also think about computation. When Shakespeare's Juliet asks, "What's in a name?" she is on to an important question about representation. Albert Camus' The Myth of Sisyphus raises the question of how to face the absurdity of life, and also how to detect a never-ending computation. Stories have multiple layers of meaning. They often include a computational layer. Once Upon an Algorithm is an effort to unveil this layer and offers a new perspective on stories and computation. I hope that stories will be appreciated for their computational content, and that this novel point of view will spark interest in computer science. Introduction. Computation plays a prominent role in society now. But unless you want to become a computer scientist, why should this prompt you to learn more about it? You could simply enjoy the technology powered by computation and take advantage of its benefits. You likely also don't study avionics to make use of air travel or seek a medical degree to benefit from the achievements of modern healthcare. However, the world we live in consists of more than man-made technology. We still have to interact with non-autonomous objects ruled by physical laws. Therefore, it is beneficial to understand the basics of mechanics, simply to predict the behavior of objects and to safely navigate one's environment. A similar case can be made for the benefits of studying computation and its related concepts. Computation is not only revealed in computers and electronic gadgets, but also occurs outside of machines. In the following, I briefly discuss some of the major computer science principles and explain why they matter. Computation and algorithms. I invite you to perform the following simple exercise. For this, you need a ruler, a pencil, and a piece of quadrille-ruled paper. First, draw a horizontal line that is 1 inch long. Then, draw a vertical line of the same length, perpendicular to the first, starting at one of its ends. Finally, connect the 2 open ends of the lines you drew with a diagonal to form a triangle. Now, measure the length of the diagonal just drawn. Congratulations! You have just computed the square root of 2. See Figure 1 in the bonus PDF. What does this exercise in geometry have to do with computation? As I explain in chapters 1 and 2, it is the execution of an algorithm by a computer that brings about a computation. In this example, you acted as a computer that executed an algorithm to draw and measure lines, which led to the computation of the square root of 2. Having an algorithm is crucial because only then can different computers perform a computation repeatedly and at different times. An important aspect of computation is that it requires resources, such as pencil, paper, and a ruler, and takes time to carry out.